In this video, we're going to look at magic square. In particular, this question says, a magic square has the property that the sum of the three numbers of each row, column, and diagonal is the same. What is the number in the center of the magic square below? So in this magic square, which is a 3 by 3 square, we have the sum of each row. So each row, there are 3 rows, and each column, 3 columns, and each diagonal, there are 2 diagonals, this one and this one. All those sums are the same. What is the number in the center of the magic square below? What is this number in the question mark? Now, what are the general approaches for magic squares? There are several considerations come to my mind. First, there's a very common method we use. If we know the numbers, like the total numbers that can be fit into these magic squares, then we can calculate the whole sum. We can calculate the whole sum. If we know all the numbers. Some of the magic squares will say that just fill in 1 to 9, for example, into this 3 by 3. If we know all the numbers. What's the benefit if we calculate the whole sum? If we calculate the whole sum, then knowing that each column or each row has the same sum, let's say if we say the sum is S, right? Then if we adding all those 3S together, 3S will be equal the sum of all numbers. And from here, we can calculate S. And knowing the S, the common sum, is going to be very useful. Now, this does not apply to this question because we don't know what are the numbers going to fill into this magic square. There's another very useful thing we can know from the property of a magic square is the following. If a row, like let's say this row, and a column, which they have to share one number, right, cross at this point, then the sum of the remaining 2 numbers has to equal each other. So if I know this and this cross, then the sum of this number and this number, this plus this, has to equal this plus this, because the sum of this row equals the sum of this column, right? So this property, let's say, is the cross property. I'm going to just call it cross property. And we're going to use this cross property to solve the problem at hand. So let's see. So we know there's 9, 19, and 3, 17, and there's a 15 here. By using the cross property for this column and this row, okay, this number is shared. So that this number plus this number is going to equal this number plus this number. So let's using the cross property for row 3 and column 3. We get this number has to equal, this plus this has to equal 17 plus 3, which is 20. So this number has to equal 5. Now, knowing this is 5, now we know that the common sum for each row and a column is going to equal 9 plus 19 plus 5. So the common sum (9 plus 19 plus 5), that's going to equal 28 plus 5 is 33. Knowing the common sum, now we of course can find a question mark. Basically, we know that 19 plus question mark plus 3 equals 33. So question mark equals 11, right? Actually, we don't even need to using or finding the common sum. We can apply the cross property after knowing the 5 by applying row 3 and column 1. Now, this is the common number, so this question mark plus 3 equals 9 plus 5. So question mark has to equals 11. And here, basically, I'm listing the two very, very useful approach to solve or consider magic squares. First is there a way to calculate the whole sum? And I remember there's a AMC 10 question related to this. It gives you all the numbers that are going to fill into a magic square. And then from there, you can easily calculate what's this common sum for each row, each column, each diagonal. The other technique is this cross property. By knowing this, the sum is the same, and if you look at the cross row with a column, you will know that after removing this common element, the sum of the remaining numbers has to be the same. A variation of this cross property is extremely useful in solving Sudoku puzzles. And maybe we can talk about Sudoku in a different lecture.